We're going to determine whether a series is convergent or divergent, and then if it is, find its sum. I'll go ahead and tell you this one's going to be convergent, and I forgot to put a plus dot dot dot. This series is 1/3 plus 2/9 plus 1/27 plus 2 over 81 plus 1 over 243 plus 2 over 729 plus that dot dot dot. What we see is the denominators, are 3, 9, 27, 81, 243, 729. They are powers of 3 and they are increasing. The numerators go back and forth between 1 and 2. In order to figure out whether this is convergent or divergent, it would be good to be able to write down the nth term, just some generic term in the series. I'd like for you to pause the video and see if you can do it. And yeah, my voice is like that for a reason, but pause the video and give it a shot. Now, the reason my voice went like the way it did is because this isn't really one series. It's actually two series being kind of shuffled together. One series is the one that has the numerators of 1, so 1/3, 1/27, 1 over 243. And then the other series is the one with the numerators of 2, 2/9, 2 over 81, 2 over 729. Now, there actually is a way to express these as terms of a single series. It involves using a cosine in the numerator, and then things go all haywire for what we're about to do. But for in this case, the piece of ingenuity required is splitting it up into two series. The one with that starts with 1/3 is geometric. The first term A is 1/3. The common ratio R is 1/9. And since R is less than 1, that series is convergent. The series starting with 2/9 is also geometric. Its first term A is 2/9, and its common ratio R is also 1/9. So let me join this with an equal sign, and then this will equal, we're going to use the formula for a geometric series, 1/3 over 1 minus 1/9 plus 2/9 over 1 minus 1/9. Simplifying the denominator, we end up with 1/3 plus 2/9, and noting that there are common denominators, that's 1/3 plus 2/9 over 8/9. This will turn into 5/8 once we simplify the arithmetic. Next, we're going to find another sum. It's the sum as n goes from 1 to infinity of the natural log of n over n plus 1. We're again going to express this as a sum of terms. We're going to expand it out, and I'll write it as a finite sum. S sub n is equal to, when n equals 1, we have the natural log of 1 over 2. When n equals 2, we add that then, so the natural log of 2/3 plus the natural log of 3/4 for n equals 3 plus dot dot dot. And I'm going to give the last two terms here the natural log of n minus 1 over n, that's for n minus 1, plus the natural log of n over n plus 1, and that's for n. Right now, this looks like it may be a little bit hopeless, but this follows a particular pattern, and what we're going to be able to do is use properties of logs. We have a quotient. So we're going to express this as the natural log of 1 minus the natural log of 2. Plus the natural log of 2 minus the natural log of 3, where the 1/2 became natural log of 1 minus 2. And when the argument is 2/3, we have the natural log of 2 minus the natural log of 3, plus the natural log of 3 minus the natural log of 4 for the next one, plus the natural log of n minus 1 minus the natural log of n, plus the natural log of n minus the natural log of n plus 1. And what we notice is that there are some terms that appear in pairs, right? Negative natural log of 2 plus natural log of 2, those are going to subtract out. Negative natural log of 3 plus the natural log of 3. And if you notice the pattern, you're going to realize the natural log of 4 is going to end up being subtracted out. At the end, the natural log of n and negative natural log of n, and everything between the natural log of 4 and the natural log of n minus 1, they're all going to end up offsetting each other, and we're going to have a bunch of zeros. Speaking of which, natural log of 1 is also 0. So the nth sum, or the sum of the first n terms, the nth partial sum, is equal to negative natural log of quantity n plus 1, which means that s is the, is equal to the limit as n approaches infinity of the negative natural log of n plus 1. Substituting infinity in place of n, we're going to end up with that s is equal to negative infinity. Since that is not a finite number, we're going to conclude that the series is divergent.